Welcome to Spring LIB.
So let's draw the diagram of what the problem looks like. So we have a drum, massless drum with radius r, and then from the drum there's a rope that's connected, and then there's a mass which is attached to the drum. Now we'll be using the power output of the motor to see uh, to find out the velocity of this weight that it needs, or the constant velocity of the weight that it needs to go up. So first of all, um, we'll we're given the output of the motor shaft, and we know that power is equal to force times velocity in linear motion. And if we convert that to rotational, we know that force is, so let's actually make a little chart here. So let's call linear by L and rotational by R. So the force in rotational will be torque, and the velocity will be omega. So that means this power output in terms of rotational motion will be tau. Let's call it z, just to show that it's the direction. The direction is in z direction. So that's the power output that we have. Now, so we were given omega in terms of revs per minute, we need to convert that to radians per second. So omega z is given as 4,000 revs per minute. So let's convert that to radians per second. So we'll have 2 pi radians per 1 rev, and then 1 minute has 60 seconds. So finally we get 418.9 radians per second. So that's our omega z. So we can figure out torque from there, which is P over omega z. So that's going to be 1.5 times 10 to the power 5 watts. So we converted kilowatts to watts. And then omega z is 418.9 radians per second. And that gives us tau as 358 newtons meter. And so that's the torque that we need. Now in part B, we need to figure out the um, in part B, we need to figure out the tension that it needs to lift the weight. So we know that the system has a constant velocity in upwards direction, which is V. Then we have tension, and then we have the weight that's directing downwards. Now, since we our a or acceleration is 0, since the weight is going up at a constant speed, so that means our tension should be equal to the weight. Now we have already known that torque is tension times r, because we know that torque is force times r, where force is tension in our case. So from here we can figure out the tension, which is torque over r, which is 358 Newton meter divided by 0.2 meter, which gives us the tension as 1790 newtons. So that means since we figured out that tension is equal to weight, so our weight will be 1790 newtons. Now for part C, we need to figure out the constant velocity. So since the velocity is constant and there is no slipping, so we can set V equals to R times omega. So omega is 418.9 radians per second. So V will be 0.2 meter times 418.9 radians per second. That gives us 83.8 meters per second. Thank you.